Not this time. No, not this time. It's totally made up. Pure fiction.
We're not talking about this or this. We're talking about this.
Hey, welcome to Making Space. My name is Pat Schuff. We continue our discussion on fabrication labs. Today we're going to look at various issues around a lab. So one of the questions comes up is, do I build something or do I buy it? If I'm going to go fabricate something, is it cheaper to buy it? And how much time and materials will it take to build it? A few other things we'll look at are things that are typically not covered in training. Things like if I print something and it starts to peel up, how do I keep it from peeling up during the print process? If I've got something that has a large arch or open window or something that needs supports, how do I add supports? And then practical things like what tools do I need in a lab? What hardware is needed to help pull things off of a print platform? And then finally, we'll end up looking at if you're creating your own lab, which 3D printer should you buy? Do you go for economy? Do you go for quality? Do you go for minimal consumers? There's a variety of things that you need to look at. Now, before you start prototyping something, a good thing to do is go look at what's the comparable price. We're going to start with something very simple, a paint pyramid, which is basically used to stand off an item from a table so you can paint on top and on the sides at the same time. It's good for a variety of things. They're cheap, they're small, they're easy to do, and they have some practical applications for 3D printing, which is kind of fun to play with. So looking at this, just do a Google search, come up with 10 of these for $7 or 40 of these for $16. So the price ranges anywhere from 30 or 40 cents per triangle up to slightly less than $1, 60 cents per triangle. This is a good place to start when I'm trying to build something. Auto parts is a good place to look because auto parts are incredibly expensive and you can usually print them for cheaper. And this is the first analysis that I typically do when looking at trying to prototype something. The second thing I typically do is to go look on Thingiverse or Utilamaker or some other site that has designs. Can I find this design and how difficult does it look to print? If I don't have to design from scratch, that reduces my time, or if I can take a design, modify it quickly and easily, that simplifies the fabrication. A few of the things I look at when I'm downloading something from Thingiverse. First, how many downloads have there been? For this one, there have been about 1,000. Second, any comments, any critiques or complaints? Third, what does a typical print look like? Not only photoshopped or customized, but a sample print. And then finally, how big is it? If it's a giant multi-piece thing, I might reconsider doing this. Once I get everything loaded into Cura, make copies of it, I look at the slice to see if I've done everything level. Is everything on the same level? In this example, there's a triangle that's lower than the other ones. So I had to reset the height of everything to make sure everything was on the same level, because when this printed, it would have printed with an error. When I first printed this, the triangles that made up the base peeled up. When they printed, they curled a little bit, and the head kept bumping into it. The way you can stop the peel-up action from small pieces from the adhesion plate is to go into the Build Plate Adhesion in Cura and select a brim. And what a brim does is it puts an edge around the piece, which adheres it to the table a little bit better. So the difference between a raft, a skirt, and a brim in the pull-down menu, a raft is a foundation that you print on, and you can peel the raft off in theory. I really don't like the rafts. The MakerBot Replicator Mini enforces rafts on everything, and for smaller pieces, it's impossible to peel off. A skirt basically cleans the print nozzle before it prints the actual item, and then a brim kind of expands the skirt and attaches it to the item so that the edges of the item don't peel up. So 2 things to know after adding brims. First, there's a layer around each of the triangles, the foundation base, that is used to keep the foundation stuck to the build plate. Second is it does consume more plastic because the brim does take more plastic and more time to print. By printing the brims around each of the triangles, it added about 30 minutes worth of time to the total print job. So this is an example of what the paint triangles look like with a brim. Notice there are 6 of them that are organized in staggered fashion, and the brims attached to each other, which gives it better adhesion to the table. Another option with the Cura slicer is to add supports. If I've got an arch or a window or an open area, I might want to put supports in. As I was talking to one of the guys at the shop at TXRX, he suggested putting supports underneath this because there's a slight arch, and to be honest, it's less than 5 millimeters, so I didn't really need an arch. And the pyramid has some questionable areas, and he thought I needed an arch support, so I went ahead and did it just to see what would happen. When you go into the Cura slicer and look at different slices, you'll notice the green area is the supports that are being built. The brims are larger, there are supports in the center, and they climb all the way to the top, and it's printed. Now, notice this takes 7 hours instead of 5.5 hours, and it takes 50 grams of material as opposed to 40 grams of material. So it takes substantially more material to print it with supports. The thing I really don't like about supports is it adds a lot to the post-processing. Notice on the left we have a very smooth, very clean inside. It printed no problems at all. There were some issues on the span. The first layer was a little stringy, but beyond that it was pretty clean. Notice all of the parts I had to cut out of the right-hand side. It took a good 5 minutes for each of the pieces to cut out all of the supports. I don't think it was worth it. If I were doing something like wings or an arm extended or a cape or something that had a very 90-degree overhang, I would definitely use supports and cut them out. But for something like this that's got a 30 to 40 degree angle, really don't need the supports. When it comes to post-processing, there are kits you can buy. This is a 3D printer kit on Amazon that is put together. It has X-Acto knives, it has tweezers, it has diagonal cutters, it has a metal putty knife where I can peel things up off the print surface. There are a lot of tools that are needed and are necessary for 3D printing. A lot of post-processing, a lot of fine-tuning, getting rid of stringing, getting rid of supports. The tiny picks on the top left are used to clean the print head with. There's a lot of maintenance that comes along with 3D printers as well as post-processing of prints. Here's an example of a piece that would totally fail without supports. It's basically a 5-inch piece of C-joint with ruler marks on the top side and a gap in the bottom part for parts that slot in. If we printed it like this, it would sag in the middle. It would never work. It would not print the way you'd hope it would. The simple solution for a piece like this is to just go in and go to the printer options and tell it to print supports, and it'll print supports underneath the raised bed part. Going into the slicer tool, we notice there's a lot of supports. In fact, for the first few layers, there's more supports than there is actual material. And it's going to take about 4 hours to print this and 23 grams of material. There's got to be a better way to do this. Alternatively, if we flip the object, rotate it 180 degrees along the longitudinal axis, in this case the green axis, we'll notice that the measure marks that were on the top print just fine because there's a very, very small gap. But the large gap that exists between the legs aren't a problem anymore, because when we go through the slicer, we'll notice that it's mostly air between the legs. So by flipping the piece over, we consume about 30 minutes less time and a third of the plastic material. We get the same part. It takes less time, consumes less material, which means we can print more of them cheaper. So doing something like this rather than using supports makes total sense. Going back to the introduction, we've covered, why you would build something versus why you would buy it. Try to find something already engineered so you don't have to start with a CAD diagram. If somebody's already designed it, use that. If you're having issues printing, look at brims as a first option, look at supports as a second option, and look at flipping as the third option. When building a lab, tools are an important thing. Tools tend to disappear. You want to get good tools, but you want to get tools that are inexpensive so that you can replace them when they disappear and have a storage place for them. The final issue to talk about is what type of printer should you buy? Do you buy the best printer? Do you buy the cheapest printer? And then what consumables are your users going to be responsible for? When it comes to printers, there are three things you need to look at. First is quality. You don't want to buy something that's cheap and is going to constantly need maintenance and is going to break. Second is price. You can get a $1,000 printer, or you can get a $400 printer, or you can get a $180 printer. The size of the print bed is going to dictate the cost to some extent, but the quality of components is going to dictate the rest of it. And then the third is, can I service it? Are there parts that I can take apart and put back together? The Prusa, for example, you can buy as a kit, so you can pre-assemble it. You can buy it pre-assembled, or you can assemble it yourself, so you get to know how it works together. The important thing is pick a printer, stick to that printer, and buy a bunch of those printers. How do you find out which printer is the right one for you? To be honest, there is no single answer to that. Different labs have different printers based on their experience, based on their knowledge base, based on their economy. A lot of shops go with the Ender printer. A lot of shops go with the Prusa. A lot of shops go with the Utilimaker printers. Very few of the shops are going with the MakerBots just because they're harder to maintain. It's harder to get parts, and the printhead is encased, so it's difficult to manage and maintain the printhead itself. So the final thing to consider when looking at printers is the build volume. How large a space can I print, and what is my community trying to print? If it's a bunch of small parts, then buy small printers. I might do a mix of large and small, like a Prusa Mini and a Prusa MK3S, just because I can have a variety of sizes, and then buy more of what people use. Buy 2 or 3 of each, and then as people use more and more, phase the ones they're not using out, but stick to one vendor. Don't buy a bunch of Enders and a bunch of Prusas and a bunch of Sidewinders. Buy all of one type, and that way some of the parts will be interchangeable. The final thing I recommend is watch videos on YouTube of print farms. There are people who have tens or hundreds of printers, and reach out to them. Ask them what their highest maintenance points are, what their typical maintenance is on 10 printers. Try to gauge how long it's going to take you on a weekly basis to tweak and tune and keep the printers running. So if you're a member of a lab and have access to printers, what kind of printers do you use? If you're maintaining them, what's the biggest maintenance headache that you have? Is it jammed filament? Is it unlevel beds? There's a variety of things that have to be tweaked and tuned on a regular basis. Hopefully this was helpful. It's not intended to be a beginner discussion, but it's more of a level 2 after you go into your first level training, after you've printed a few things and want to know, hey, this didn't work. How do I fix it?
While some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.